on this warm-up, who can help me fill out these blanks on the right side? So I'm just interested on the empties on the right. Claire?
Elsa,
Elsa, yeah, it's not my fault.
My sister.
Elsa, I first.
So it's multiplying by 3.
So you're seeing a relationship of times 3. Okay. So then what would you have for the blanks there?
4.5 would be 13.5.
Times 3 is 13.5, and then times 3?
Oh, the fraction didn't print in for us.
So I got 33 halves,
I just put in 3x.
which would be 16.5. Okay, so times 3 to get left column to right column. Who can help me get right column to left column? Josiah?
The right column to the left column is like dividing it by 3.
Okay, what would I get?
It's like 3 divided by 3 is 1. So I just figured that out from that one. So
Yeah.
36 divided by 3 is 12.
Okay.
And then 46.5 divided by 3 is 15.5.
So as we went left to right, we multiplied. As we went right to left, we divided. Like they undo each other, right? Those are inverse operations. Does anybody, for this next slide, can anybody identify which equations would be shown here?
Well, we didn't print, so we didn't know.
Yeah, so like, let's just talk about it. We had that times 3. We have a couple options here with that times 3. Ivy, which one do you think it is?
Oh, well, I actually have the divided by 3 one.
Okay, so let's start with the first relationship. The times 3. Which one, A, B, C, or D, shows that one? Vinny?
Would it be an
So I see times 3. A says the base is equal to 3 times the area. So let's think about that for a parallelogram.
It'd be D.
Yeah, why are you saying D instead?
Area equals 3 times the base.
Yeah, we multiplied the base by 3. So they both had multiplication of 3, but we wouldn't want to triple the area. Okay? So next, let's look at that divide by 3 to go from the left to the right column, right to the column, the left column. Which one would that one be? I see 2 divide by 3s. Which one would be the right one? What are they?
B.
You're thinking B? So if we take the area and divide by 3, we get the base. So here's where these both come from. Would you guys agree area equals base times height?
Yeah.
So if I want to know the height, I could divide both sides by the base. And if I had area equals base times height, and I wanted to know the base, I could divide both sides by the height. Right? And if we have equivalent, from our lesson 6-7, if we have equivalent fractions, we can make, or equivalent, not fractions, we can make equivalent equations by doing the same thing to both sides. So we have equivalent equations here, different applications depending on different needs. What you need to do is find out how far these volunteers will have to clean up in the road, whether they have 8, 10, 25, or 36 volunteers. And then write an equation to simplify or show what you did. So let's chat here. Who can tell me how they got how far we'd go with 8 volunteers? What did you do? Sean?
I did 2 divided by 8, which is 0.25.
So you split up those 2 miles among 8 people evenly, and I might do it a little different, but same thing, a quarter mile each. All right, 10 volunteers. Who can tell me what they did? Vinny?
0.2 miles.
Okay, but I said what did you do, not what you got. You're good.
10 volunteers divided by this. No.
2 miles.
Yeah, 2 miles divided by the 10 volunteers.
And I did this. I like fractions.
Yeah, me too.
So I got 1/5 of a mile, which would be 2/10. 25 volunteers. Ryan, what'd you do?
0.08. I divided 2 by 25.
And so watch what I did here. I actually went to decimal for this one, but here's what I did first. I said 800, sorry, times 4 equals 800. Not even 1/10 of a mile, man. If you get a lot of volunteers, it's not too bad, huh? Unless there's lots of horses, still bad there. All right, D, who can tell me what they did? Ivy.
I did 2 miles and 1 divided by 36, so 36. And then I got 0.05, so I just did about 0.055.
Yeah, or 1/18 miles would also work. All right, so who's got an equation for me that I could use for like any number of volunteers? It'd work for every single one forever. Troy?
L equals V divided by 2.
If I take the number of volunteers and I divide by 2,
Yeah, because that's the length of the road that they're working on.
so I'm taking, but right here, so you're saying I did 8 divided by 2?
Oh, no.
So
said-
let's try it again.
Oh.
I said-
But we're close.
I
So I think it would be.
What am I splitting
L
up?
equals 2 divided
Two
by
divided by
2 divided by,
Oopsies.
and it makes me pick the letter N for the number. But yes, you had the right idea there. So I'm taking 2 miles and I'm always evenly distributing it between the number of volunteers,
I got one.
right? So now, what I want you to do is to give me the number of volunteers needed to get these different mileages for each one to do. All right, so that's what, and as well as an equation. Who can tell me how they got the number of volunteers if each volunteer did 0.4 miles? How'd you do it, Olivia?
We did 2 divided by L equals N.
Oh, so you got this equation, and so you did 2 divided by the 0.4?
Yeah.
And then what'd you get?
And then we got 5.
5 volunteers, okay?
Yeah.
All right, Ivy, tell me how you did B.
So the equation was, 2/7 is 2 divided by n.
Oh, 2 divided by, okay.
So then I knew like if I wasn't like 2 divided by 2 over 7, which is just 7 because you're just doing the opposite like 2 times.
So 7 volunteers there?
Yeah, so n equals 7.
I can think of a few ways to do this. I can also think of I know I want it to equal 2 miles. And so this needs to be a 14 divided by 7 to get to 2 miles kind of thing I was thinking as well. Which I know 14 halves doesn't equal that, so the equal sign doesn't matter. If you did 2 over 2/7, that is actually 2 times 7 halves, which still equals 7. There's a lot of things we could do there. All right. Did anybody just see how many times they add 2/7 to itself to equal 14? That's kind of what I just did. No? Okay, C. How'd you get it? What answer did you get and how'd you do it? Sure,
No,
C.
KC, Kai Chenlo. Is that your name?
C.
My bad.
I don't know.
Yeah, how many volunteers did you get, Cam?
I got 16. Kai Chenlo.
I got 16.
16.
I did 2 divided by 0.125.
Cool. And then 6/45. Now I want to show you how to do some of this here, okay? 6 divided by 45. And if you divided that, or 2 by that, I got to rewrite that. 2 divided by 6/45. Are you guys good with that being the same thing as 2 times 45/6?
Oh, you want to know what I
You multiply by the reciprocal, and then I can cross simplify here. I got a 1 and I got a 3. It's really just 45 divided by 3
6 divided by 45, right?
for 15 volunteers.
Oh, I got it right. Let's go. I thought I got it wrong.
So who's got an equation for me
Boom, bop,
to give me
pow.
the number of volunteers needed? Brendan?
2 divided by L equals N.
Yes, 2 divided by L. Now,
I did it with different variables.
I want to make a connection to what we were just looking at. So let's say we start with this N equals 2 over L. And let's say we want to get L by itself. The first thing we would do is multiply both sides by L. Okay, and it cancels right there. So if I did the length needed by the number of volunteers, it should equal 2, correct? Well, if I want to get L alone, I would divide by N. I'm back to that L equals 2 divided by N. That was what we looked at last time. So that's not the answer here. I'm just showing these have to be equivalent equations. And I can prove they're equivalent equations by doing the same thing to both sides. But if I needed to find how many volunteers I needed over and over, I'd want this one. If I wanted to find the length that each volunteer would do over and over, I'd want this one. Same equivalency, but different equation had a different purpose. Kind of cool, huh? Yeah. So we're all of us are only doing 1 and 2. We're not going to do 3 and 4.
Oh, we're doing lesson 9 also.
So who can tell me how they got answer for 1A? 1A. Lily?
So I figured out that there are, since there's 9 liters per minute, there's 4 minutes, so 9 times 4, and you add that.
Yeah, so you said, pretty much what you said is after 4 minutes, there has to be 36 additional liters. And 36 and 124, what'd you get? 160 liters total. Cool. Everybody on board there?
Yup. Wait.
So the challenge for the next one is I did 9 times 4/3.
Oh yeah, I got that. My bad.
Because anybody do 1.2? Pretty common mistake, 1.2. It's 1.3 is only close
It would
though.
be 1.36.
1.3 or
Yeah, but watch. Okay, guys, watch why I'm a big fan of
9
fractions.
times 1/3.
I did that.
Well, I did 9.
Check out what happens with this fraction.
And then 1/3 of 9 is
Check this out. I can cross simplify. That becomes a 1 and a 3. 9 times 4/3 is just 12. So it like plays nice.
Oh, 136.
So we get 136 liters total. But do you see why I say don't shy from the fraction? The fraction played real nice. Cross simplification. So, who's got an expression I could use if I continue to have minutes? What's Brendan?
9m plus 124.
And imagine how nice this is kind of like a function, right? I could pump in a bunch of different minutes. No matter how many minutes I pump in, this is going to pump out the answer of total liters, right? 10 minutes, 50 minutes, 52 minutes, 59 and a half minutes, 500 minutes. Doesn't matter. In for M, over and over, done. I want you to try the same thing with number 2. D is going to be a little different. So focus on D once you get there. So we're gonna reason through A. I'm not gonna do all of them. We're gonna reason through A and then use it to justify the answer to D. So, who can tell me how we would find how many liters were added? So I think the first thing we need to know is how many additional liters are there. What would we do to find that? Okay.
E minus 124.
Yeah. So I'm guessing like for A, most people did 151 and they subtracted 124 from it to see that 27 liters got added. Is that something a lot of people did?
Yes.
And then how many liters per minute?
3.
You divided by 9 to
yeah.
get 3 minutes that passed, right?
Yep.
So check this out. Here's what we're going to do. Let's make the connection between this and letter D. So here's how we're going to do it. I know that 9 times the number of minutes plus 124 totals how many liters are in there, right? So I'm going to put a T for total liters. So if I want to get M alone by making equivalent equations, check out what I can do. Minus 124. Can anybody find that from higher in my work? Look it.
That's what I got too.
You did it. I'm not done. I'm just showing you. Remember in our work, we subtracted the 124 to see how many liters were left?
That's literally that.
You guys see this up here? Is this right here? Do you guys see that? Because this connection's big. Because you reasoned through this already.
Yeah, so
Then, what did I do?
divided by 9.
So check out how I get
Divided by
M.
the amount of liters.
I divide this by 9 to get total liters, take away 124 to see how many liters are left. Divide that by 9 per minute to get total numbers of minutes. What I'm showing you is, for those of you that reason through 2A like we showed here, that is what you do to isolate the variable M. And you want this equation because guess what? Now for B, just slap that in there. For C, slap that in there. For any number of liters, slap it up in there, okay? Not too hard though, be a little gentle. Okay? Slap it in there, baby.